Research and innovations. Before we get started, I want to introduce the speakers here. Professor Rao Tumala, I think everybody knows Professor Rao Tumala in the world of packaging. He's written quite a few books. Professor Rao, he holds Joseph Petit Chair of Electronics Packaging, and he's been associated with Georgia Tech for many decades now. He's a founding member of NSF Engineering Research called ERC and PRC, and he's also brought the vision of system in a package many, many decades ago, just when the world of multi-chip packaging was evolving, and here came the vision of system in a package that time. Before Georgia Tech, Professor Rao was IBM fellow for several years, working in areas of displays, magnetic storage, and packaging. He holds over 70 US patents and more than 300 publications in the industry. Professor Rao. Okay, then I'd like to introduce Dr. Surya Bhattacharya. Dr. Surya Bhattacharya has a PhD in electrical engineering from University of Texas. He's director of System in a Package at A-Star IME Research Institute with 30 years of experience in CMOS devices and package scaling. Before IME, he was director of foundry engineering at Qualcomm. So far what you heard, Professor Rao, Surya, both industry, academics, great combination there. Next, I'd like to introduce Dr. Devan Iyer, PhD, is Senior Vice President at Amkor Technologies, managing power and automotive product business units there. Before joining Amkor, he was at Texas Instruments for 12 years, corporate vice president responsible for design, assembly engineering technologies, and manufacturing. He brings more than 30 years of experience in global semiconductor industry here. Dr. Iyer has also been associated in past with Georgia Tech, spending some time there in terms of being a faculty, driving the research there as well. Next, I'd like to introduce Amrit Manwani ji. He's truly, if you look at most recent venture, I'll start with that, founding Sahasra Semiconductors, AMTP OSAT plant, memory packaging in India, and before that, Manwani has been managing Sahasra Group. He's been chairman. He's completed several Alcina assignments as well. His ventures have ranged in many states of India as well as offshore in East Africa as well. So truly global experience bringing to the stage here. So with the introductions, before we get started, I thought we like to spend a minute here for us to align and recognize what does the world of packaging research and innovation landscape looks like. Very often we associate the world of packaging with what we see in front of us, but there is a lot more to packaging research, and that's the part that we don't normally see. So if you look at packaging research, it links to just about every element of product development, flow, and the supply chain. And you heard about the supply chain earlier today. Starting with the system architecture, the chip IC layout, global interconnect optimization, I/O design, the interconnect technology, the fab packaging interaction, the ESD, and package design. Package design is typically what we often talk about, the thermal, the stresses optimization, all of that. And of course, that has to link with the manufacturing processes and the defect management. So one key reason I'm trying to emphasize when we think about packaging research, it's all of these elements that really matter, and they all need to be linked, they all need to be addressed. What we also need to recognize is the technology development truly is a very strong collaboration with the equipment and the material partners. You heard an earlier discussion today, the supply chain leaders. The leaders, they've been in the industry since the dawn of semiconductors. The first semiconductor chip was using KNS wire bonder ever built. KNS is still the industry leader. And that speaks to the scope of research that are like for all of us to recognize here. What we also need to recognize is when we talk about performance, it's tightly coupled with market segment and applications. Again, performance typically, we think about compute performance. It's a lot more compute performance. The third point to be noted as we look into the landscape of research is that packaging research is globally distributed. And we need to accept that this has been the success model for the last 40 years and managing that global research. Significant of packaging research is driven today in OSAT world with equipment suppliers and the material suppliers. And the message in there is when we think about R&D and the close collaboration. What we also need to accept and recognize is the global competencies need to be leveraged in area of research. It's a coexistence of the whole ecosystem. While a lot of the packaging ecosystem is in Taiwan, the research is global all around the world. So as we embark on the journey of leadership in packaging research, we need to pay attention to all of these elements here. So with that, I think I'll move on to the panel discussion here. So as we embark on the panel discussion, I think first will be a question here to the panel is, what are the research models, consortium models that you would like to share with the audience here, where you're seeing success, what works, what doesn't work? So with that, I'll ask Professor Rao to take the lead and share his thoughts on that with us.
Morning. First, thank you very much, Ham, for including me in this panel session. First, I want to congratulate you, Gurshu, and your CEO, and the entire Micron team for taking the very, very bold step of putting manufacturing for the first time on a large scale, okay, in India. That's wonderful. I view this as next to what TI did, okay, bringing the design center in 1987. So this is the second biggest milestone, okay, in adding to this number of technologies that India needs in becoming the entire, what I call a system country. The end goal for India, in my view, should be system country, because India already has design and software. If you bring manufacturing, the only thing we need to do is really what you said is packaging research and development, which in my opinion, India is totally capable of, like no other country. Okay, I don't have the time to go into the details, but I see that clearly, that India, okay, with its massive IITs, okay, a lot of faculty all under one roof to be able to do what I call large-scale R&D like no other country, okay, inviting a lot of companies to come to India just for R&D alone, okay? So that gap will be gone as well. So going back to the question of a global, so let me also say for a minute that I've been in this business for a long, long time, both at IBM and Georgia Tech. Packaging has changed a lot, okay? Most of you think of packaging means, I have this device, I got to package it. That's the wrong way to look at it. The end goal of packaging to me is a system. If you think of system, okay, the system needs to be ultra miniaturized. Okay, ultra miniaturization leads to highest performance. It also leads to least amount of materials. Okay, it also gives the highest reliability and lowest cost. Anyway, look at that system focus. Packaging is all about system. Packaging is not device. Unfortunately, we thought of packaging to be device, and therefore, in my opinion, we lost 40 years. Okay, well, thank God for a company, system company like IBM, which looked at it entirely different way. Okay, even at IBM when I was there 40 years ago, we invented so-called chiplet-like technology. It's the same, up to 144 chips on a very large substrate. Okay, so here we are talking about the same thing in a way. Okay, but the point of all of that is, we should have taken packaging to mean system as opposed to device. So therefore, I keep on preaching here in India, that the end goal of everything you do in India must be system level and system level, system level. So going back to the global models, in my view, okay, as you all know, IMEC is the best global model for semiconductors. But the end goal is a system in India. The global models, in my view, are, okay, my friend in here from Miami, Singapore, okay, and we have ITRI Taiwan, okay, well known. And then there are a whole bunch of Fraunhofers, and the most appropriate one is in Berlin, Germany. So those are all what I call industrial institutes, okay, and focusing on developing the technologies and transferring the technologies to the companies. Okay, and then of course the other one is the Georgia Tech model that I pioneered at Georgia Tech. But Georgia Tech is an academic university, okay? So how does the academic university, okay, develop technologies and transfer them to companies? So I invented a very pioneering model. So I just wrote an article. I'll be happy to give a copy of that. But basically, okay, Georgia Tech being a university, it does advanced research using faculty and students, okay, which every university does. There's no problem. But the moment, okay, you go beyond that, beyond each individual technologies to integrate towards a system, universities, okay, cannot do that in my view. Okay, they're not equipped to do that for the following reason. Typical faculty is an expert in a field. System requires 20 to 50 different technologies. Therefore, how do you integrate the research of 50 faculty into one system at a university is impossible. So therefore, I invented what I call an industry-centric model, bringing global companies from around the world, including Japan, US, Taiwan, okay, and so on. Okay, let them come to Georgia Tech, place their engineers at Georgia Tech, let them work with faculty and students, taking their advances, okay, converting them to system prototypes, and then transferring that to industry. Therefore, okay, Georgia Tech model, in my view, is capable of, okay, and accomplished from concept to commercialization. This is what I'm trying to do here in India as well. No reason why India cannot do that. Okay, let me leave it at that. Thank you.
Surya, you want to add a comment?
Yes. So IME, the Institute of Microelectronics in Singapore, it's a public and private funded research institute whose goal is to collaborate with the industry on industry-relevant research. That's our goal. So we have a full-fledged 300 millimeter and 200 millimeter packaging line, which can do your 3D TSVs, microbump, RDL, fan-outs, hybrid bonding, and all of that stuff. So we basically work with the industry. And the state-of-the-art facility that we have right there in Singapore is a starting point which enables us to work with the industry in a variety of models. One of them is the consortium model, wherein we identify a pre-competitive set of problems. It could be in high-performance compute, 5G, 6G, automotive electronics, identify the problems and get the industry ecosystem together and address the problem. So it's a collectively pre-competitive type of a collaboration model. This is something that IME has been done ever since its inception over 30 years ago. So over a period of time, these consortium projects have led to what we call as one-to-one projects, because certain industry partners want us to solve their problems. Then we work directly one-to-one. That's another model that happens. Subsequently, some of the fabless customers come work with us and say, we want to bring in our manufacturing partners. So we call it a three-party model, wherein we work with the fabless customer and transfer the advanced packaging technology to their manufacturing partner. So there are a variety of models that are available as a research institute, and I think each of these give a great flavor and a great starting point for what the Honorable Minister to this morning referred to as the ISRC. Start with state-of-the-art or good facilities, launch consortia projects, go one-on-one, go three-party also. And I think it's really great that, somewhat similar to Singapore, which has a 30-plus year history in semiconductor fabrication and OSAT, India is right here right now, and it's a great time to start the R&D model also. Thank you,
Thank
Heen.
you. Devan, would you comment on what your thinking is and on the research models here? You've been in the industry, on the research side, manufacturing side, design side.
Thanks very much for thanks very much for having me in this panel, and congratulate Micron leadership team to have the first assembly and test factory over here, following the footsteps of Texas Instruments, who came in and started the design center and the design capability in 1984-85 timeframe. Being a graduate from IIT Kharagpur 4 decades ago, spending about 35 to 40 years between General Electric's Infineon Technologies, Texas Instruments, and right now in Amcor. So it's an OEM, IDM, OSAT experience that I'm sharing. And I had the opportunity to be at IME Singapore, developing the advanced packaging capability in mid-90s, late 90s, and part of Georgia Tech Packaging Research Center with Dr. Rao Tumula as well. So that's my brief experience. Answering to the research models and how research development can lead to productization. Setting up the research goals, having the industry partnership. Surya and Dr. Tumula mentioned about collaboration with industries. That comes in as number one requirement to be successful, to lead the research to development, pertinent development in the industry, in the Indian environment. Let that be high-speed computing. We heard about that earlier this morning. Let that be in 6G communication for future requirements of connectivity, or let that be in automotive or industrial applications in the Indian market or in global market. What is the most important thing is to connect the future requirements of the industry into the research program. And my sincere advice there to be not to duplicate what has been done, not to try to do the research what industry can do. Look for what are the requirements 5 years to 10 years from now, and develop research programs and get the required funding. What industry can do is the 2 to 3 years ahead of the curve. Industry would do that, they will get into the productization. What R&D institutes and IITs and IIC can do, along with the other universities here, is to figure out what are the research requirements. Let that be in any of the applications that I mentioned earlier. Translate that into the design capability. India is excellent in design, circuit design. Co-package design is extremely critical. Chip package, PCB core design, for the future requirements, not for tomorrow's requirements, but for 5 to 6 years ahead of the curve. Define that and execute that. And I will stop there and take later on future questions.
Thank you for the interesting thoughts there. I think with this, a logical next question, since this is truly the whole area of research is so global, how do you see, what are the possible approaches you could think of or share, how the packaging research here gets integrated in the global landscape? Because we have many, many countries been driving packaging research and have leadership roles in various aspects. How do you see India here leapfrogging and being the part of a global ecosystem here? Yeah, go ahead, please.
Okay, where I stopped was India's expertise in design. There are many companies who are doing designs here, circuit design, even advanced designs. Probably they are the centers of excellences in circuit design. No question about that. Start from design for performance. How do you enhance the performance for electrical aspects, thermal aspects, mechanical aspects? If I define design as design for design for reliability, design for manufacturing, if I classify that, use the existing competencies, the outstanding competencies of design, and then proliferate that into the future requirements. How do you extend today's outstanding design capabilities for future requirements for enhanced performance? It can be for 6G communication, it can be for IoT, it can be for automotive. Yesterday there was a fantastic panel on power. If I take simple examples of power, in the context of EV power requirements, what are the design requirements that would enable us to be differentiated in research, in R&D, using the core competencies of designs in India, right? And same thing applies to the communication world. So leverage the expertise right now, the world-class expertise we have, and then translate that into the requirements of future. And definitely, packaging will not go without materials. I think the previous supply chain panel emphasized the importance of how materials are going to play, how the process capabilities are going to play a critical role in making the R&D effective for the productization. So if you start with design, go through the materials as needed and process capabilities as needed, and then excel from there.
I totally agree with, with what Devan said, and I would like to unpack it a little further. When you look at, as Devan said, India's excellence in design is world-renowned. So how do we translate it? It can be readily translated into what Rao likes to call as the D&D, right, Rao? Design and demonstration. System design and demonstration. One way is I look at where I work at right now, IME Singapore. We offer package process design kits for a variety of packages. It could be the power packages that Devan talked about, RF packages, high performance packages that was talked about with high bandwidth memories and CPUs and GPUs to make interposers and 3D stacked devices. Using those, the Indian experts, we had a session yesterday with over 70 faculty with specific identified leads by Professor Rao. They can readily start using these design kits and design them. These systems subsequently, as ISRC is coming up to speed and setting up the state-of-the-art facility, these designs can be fabricated right a few hours away from here in Singapore. Can design and test it. The beauty of design is it allows for so much creativity which is available from the professors. So that's something that would make it immediately relevant, the work that is done here. And as the state-of-the-art facilities come on board at ISRC, guess what? That creativity is going to go through another hockey stick at that point.
Yeah, thank you. Professor Rao, please share.
Yeah, the best way to bring India's R&D to global level, first I think you have to assume the R&D in India must be at global level. sometimes I hear people tell me, can we do yesterday's technology? No, nobody is interested in redeveloping yesterday's technology. So the first step, you got to accept India's R&D from here on must be at global level, which means next, what next? What's the next generation of technologies, okay, that India should develop? So that automatically, if we can undertake global level R&D in a massive scale, which India incidentally is capable of, unlike almost any other country, for the following reason again. Okay, because of all the IITs and ISC, with 15,000 faculty. So in my opinion, all you really have to do is take about 100 faculty, each advising about 4 students, and therefore that's a 400-person plus 100 faculty, 500-person R&D team, okay? And let's suppose they undertake about 50 projects with that 500-person team. So all of that from the academic world only, doing a global level. While you're doing so, okay, you need to make sure that you're able to attract a lot of companies to come and be part of that. If you don't bring companies, the value of the global level, okay, global R&D will not be as useful to India. So as you develop R&D to global level, okay, you will more than likely, in fact, I'm sure you'll attract a lot of companies to want to work with, okay, to want to work in India with Indian faculty. And therefore, you end up integrating, India's R&D, into global, not only global academic level, but industry level as well, feeding to eventually into manufacturing. So India is totally capable of doing that. That's what are some of the things we have a number of faculty here already involved in that process. So there's absolutely no reason why India cannot be totally successful in that process.
Thank you, Professor Rao. Let's move on to the next question here. As we talk about performance means different things in different market segments. So please share your thoughts. I think we all know about compute performance. It'll be good to share a few examples of performance areas other than the compute performance. So my question is for Dr. Devan here to start with, since he's exposed to so many different market segments with his experience at TI and now at AMCO.
Sure. Thank you. So when we talk about performance, connecting to the package part of it, right? And I would say packaging was an afterthought. 30 years ago, if you really look at circuit design, people do the circuit design and then do the fab and then throw it over the wall. Hey, let somebody assemble it, okay? And then ship it. That was packaging. Things have changed over the last 20, 25 years, purely because of the performance requirements have gone up. Those performance we can define in the terms of high-speed computing, wireless connectivity, IoT, sensors, automotive, industrial, all the communication, all the market segments, we can talk about it. But the performance requirements for all those market segments are also varying. The chip designs have significantly varied. Accordingly, the packaging did not accelerate to cope up with that pace. So there was a gap. And the good thing that has happened is over the past 20 years, packaging technologies have really started getting accelerated to help up and cope up with those requirements. You saw about at least 20 new types of packages in the industry over the last 15 years. If I take simple packages like QFN, QFN was a package that came up about 20, 25 years ago in the industry, but it got accepted in automotive only 5, 7 years ago. Why is that? Because of the performance requirements were not considered as chip and package together. Okay, so when we talk about performance, each segment has got something to talk about that in defining the requirements. And the good thing that has happened over the past 5 to 10 years is people have started talking about chip and package together. And that I would call it as design for performance, design for electrical performance. When we talk about signal integrity, power integrity, EMI, all the electrical engineers here who are doing circuit design know what I'm talking about. Then there is a part of design for thermal performance, mechanical performance, connecting to the reliability, what we call as DFR in the industry, designed for reliability. That's very important. The most important thing I must talk about is design for manufacturing where cost comes in. The cost factor of packages, you might be surprised to hear that from the industry perspective if I share that. 20 to 70% of the product cost today is package cost. It's not the die cost, it's not the fab cost, it is a package cost. The packaging community as a whole have understood it, and if you really look at the productization of it, 60% on the analog product is package cost, 50 to 60%. On the CMOS side, if you can really look at the cost models that we have done, 20 to 30% can be on the package cost. And cost reduction, innovation in cost reduction, because this panel is talking about innovation, one must consider about innovation for cost reduction. It doesn't have to be innovation for performance enhancement always. Packaging cost reduction is the key factor in the industry today. And one may think that, oh, that's not a cool thing. What research can be done in reducing the cost reduction? But there are innovative ways of reducing the cost by reducing the bill of materials cost. Within the cost, if you really look at it, the bill of materials cost is a primary factor. So how can you reduce the material cost? How can we bring in innovation to reduce the material cost? These are the fundamental things that we can talk about, but not compromising on the performance, what I said earlier, right? Not compromising on the reliability. How can we bring in more and more innovation? And that differentiates the research, that differentiates the R&D from India. If you really want to be in the global roadmap, these are some of the things that will have a huge impact.
Thank you, Devan.
Yeah. So this is a very good question, very important question actually. So in the past, you all know, we look to device to give us the performance, okay? Everything else is secondary. So, for example, take microprocessor in a small computing system. We look to that processor to give it the performance. But as we all know, as Moore's law began to slow down, okay, we need to find a way to get that improved performance. Where is it going to come from? It turns out, packaging now, is critical to compensate for the loss in performance coming from the transistors. So the point of all of that, in summary, is the following. You need packaging even to make Moore's law chips, and then you need packaging to enable systems, and therefore packaging is the highest value add, to give you the performance that you didn't expect in the past. So all that means is really we have to design. We've got to design not only the device as we did in the past, but we've got to design, at system level that includes not only devices, other components like power components, thermal, on and on and on, and interconnections of all of those, and leading to a higher performance collectively as opposed to simply device as we used to. So therefore, it's also consistent with what I said earlier. The end goal of all of them is system. So if you really think of today's system is this, tomorrow system has to be that improved performance, and you got to ask yourself how to design. And the design, therefore, now leads to not only counting on just the device as we used to, but all the components and the interconnections that make up at the system level. So my reminder to all of you again and again and again is think of everything you do at system level from here on.
Thank you, Professor Rob. So, so let's move on from the discussion of performance to short-term, long-term research, and what is the industry's expectation? What would you like to see? So I'd like to start with Damratji here. Please share your expectations and what your thinking is.
Okay, I have some contrary views here. I fully agree that, India has to integrate with global research. But, we also have to look at some India-centric research, the need of the industry here, the need of the consumer here. So from that perspective, I would say that, we have to have 3 stages of development in terms of, R&D and future innovation, particularly in the Indian context. In the first stage, what we have to look at is look at the low-hanging fruits here, look at the demand, high demand areas in various segments, whether be it consumer or industrial grade memories, be it in lighting, air conditioning, hearables and wearables, telecommunication where you have need for SPI NAND, and other sectors where there is huge demand. Unfortunately, in the past, whatever packaging that was happening in the country was very low volume, addressed to very small segments of the demand sector or the industry sector. We have to now look at low-hanging fruits where there is high demand, and therefore we have to look at innovation in terms of high volume packaging. This would necessitate to bring in machine learning, automation, which would definitely lead to high volume packaging. So in the initial stage, that is where we have to look at. In the second stage, we have to definitely look at performance, and different sectors would, different industry sectors would definitely have different performance requirements. For example, in memories, what are we looking at? The communication speed, read and write speed. So we have to focus our research in that direction, particularly looking at the Indian requirements. The most important thing, as Dr. Devan Iyer also mentioned, that we have adequate knowledge, talent in terms of chip design. However, we do not have adequate hardware R&D capability, and that has to be developed in the country. Today, what happens is that there is, once you have the chip design, you have to have the substrate design done. That capability is very limited, if at all. Similarly, packaging design or lead frame design, that capability doesn't exist here. We have to have that capability developed over time. Going forward, as many speakers have said earlier, we have to look at developing, putting R&D effort in material sciences. We have to look at newer materials because the materials are not available in the country. So we have to have adequate research done at our IITs and other research institutions where we can develop our own materials which can be used in the country. We are, as of today, completely dependent on all materials, be it die bonding material, be it gold or aluminum wire or whatever. So we have to develop those materials in the country. In the long term, and when I say long term, meaning 4 to 5 years, my perception is like this, that we have to have all the 4 stakeholders aligned: the academia, the government, the industry, and the consumer. And when I say the consumer, that means where the demand comes from. So all these 4 stakeholders have to get together and request our research fraternity to work with all the rest to come out with products and designs which are useful not only for the country of India, but for the entire globe. That is how we will be able to integrate in the overall global supply chain.
Okay, thank you, Amritji. Surya,
Yeah, I have a
you
quick
can add
point
one.
to make, Amritji. I think it's an excellent point. When it comes to research problems, it's not either global or local problems. It is both. Yeah. And when you look at the research problems, you have these technology readiness levels. They call it TRLs. The low TRLs is where the IITs and the IISEs are going to really take off. But then at the high TRL levels, when the industry is readily having, I need a solution for this problem, and I bet you when Micron has this new facility up and running, they will be having problems. They would like to have local solutions to the local problems. It will have to be solved by the future ISRC.
Thank you. So at this stage, I'd like to open the discussion to the audience. And I see quite a few hands.
Thank you, panelists, to put all the dots in right slot for stepping up the research in which areas India need to focus and the way we need to go from concept to commercial, 1 to 1 or 1 to 3, or advanced materials, or research beyond what we have today. But my question is, what would be your suggestion that India need to take approach to connect the global research supply? What are your thoughts on that? Means where the global research is going on, how India can contribute or connect the dots out there. Second question is for the power. Power semiconductors also require certain kind of a packaging. So what will be a suggestion and your ideas and how India should adopt that?
So are you talking about how to bring India's R&D to global level? Yeah, so first every R&D must be global. So wherever you are in India, okay, you got to bring whatever you're doing to global level. Okay, so if you do at a global level, okay, India being somewhat a lower cost, I hate to bring this cost into the discussion, but you can do R&D here much lower cost than we can do in US. So if we can do really a massive R&D in a number of areas at lower cost than other places, companies will be very much interested in wanting to work with you, okay? So therefore, all you got to do in each area that you choose to do R&D, and we're now in the process of talking about 12 different areas in India, okay? If you integrate all of them, you end up forming a system, all the way from system design to fabrication, integration, on and on and on. So all you really have to do is, okay, think of really faculty and students in each area, but also, okay, attract large number of companies from outside India and inside India to be part of that each technology. Okay, I am absolutely sure, having talked to many of them already, that many companies, in fact, I have not heard a single company out of about 100 companies I talked to in the last 6 months, that they will not be interested in working with India, just R&D alone, okay? So all you really have to do for India to be successful, in my view, I only see 2 foundational things India need to do, okay, beyond where it is today. One is R&D, okay, massive R&D. The other is workforce development. Okay, if you have those, that's all the companies need from you, from the academic world. Only 2 things. Give us the next generation of technologies that are globally competitive, and then develop the workforce, okay, that's globally competitive as well, which are easily doable in my view, because I have done that, to be honest with you, okay, back at home in US. And you can do actually much better because you really have a very cohesive system in India, unlike US. US universities are, okay, independent. They're all independent of each other. But one beauty of Indian academics is they're all under one roof. And therefore, you can really bring in the best experts, not only from here, everywhere, by topic, and then have them form teams. And if you can propose a global level R&D, which end up being lower cost, so you'll be able to attract lots of companies, you automatically become a global. Okay, that's simple in my view.
I just want to add a comment. I think in the beginning I stated the R&D is a collaboration between academia, industry, equipment supplier, material supplier. Then by definition here, this R&D activity truly is global, because all these 4 elements, they do not exist in one
country.
This is what, sir, we would like to understand how India can be connected on those dots.
Yeah, one of the ways, if I may say, one of the ways I can think of is connect with the startup companies. I mean, I heard two wonderful presentations this morning coming up with innovative ideas. I think all that we need is to connect the research through the startup companies. I was introduced to another company who was talking about LSAI in optical interconnects. It's based in India. You know, so that research needs to be there to support the startup companies, because startup companies need a lot of ideas and support to execute what their company focus is, right? So there are ways of getting the global attention and global visibility of the Indian research by working with different models like that.
One of the challenges that many of our partners face is they have designs, but they don't know where to prototype, because large manufacturers, they are always talking about how many million units do you want us to ship, but sometimes a startup or a new idea from a top-notch professor from an IIT or an ISC or any other institute, university, will not be able to be manufactured. And I think those are the kind of areas wherein institutes like where I work at help people develop prototypes and even do small volume manufacturing.
Yeah, if I may just add to Dr. Surya, I think that is a very pertinent point. I've heard from many people that they are able to design the chip, but when it comes to prototyping, they get stonewalled sort of. So there has to be a capability developed, at least at the prototype level. We should be able to tape out the product here in India rather than go overseas. That capability has to be developed here.
Thank you. I think we have more questions here. So,
Hey, hi. I come from the AI world. So I'm co-founder of AI startup. So in the AI world, two things are super important. One is bandwidth. Second is the amount of RAM you have, right? So for example, if you see the latest LLMs, they don't run on single chip. Even the single chip, if it contains like 80 GB of RAM, which is what A100s and H100s from NVIDIA has. So my question is there a potential for, with advancing in chiplets and packaging and interconnects, right? For chips to be made which are next gen per se doesn't require a complete fab infra, right? Just like for example, if you want to build an M1 chip or M2 Max chip, which is like 1/4 of A100, you still need a proper fab because it's a SoC. So is there an opportunity to build such a thing in India because the capital costs might be lower? So that's the question I have.
Yeah, so applications of artificial intelligence or ML into packaging, right? I will try to give some examples where we could really see some real interception today. Packaging automation is way behind fab automation, if you really look at the industry in manufacturing, right? So if there are ways of artificial intelligence can be connected to the data analytics and all those things, right? Application-wise, we are not sure. How do we intercept the AI ML into factory automations in packaging, in assembly and test? That's a direct interception. That's a direct need of the industry today. How fast we can get the things into industrial automation with a reference of assembly and test. One example, I can straight away say that.
that's a good point. So, since we are running short of time, we can have a follow-up discussion. But taking the same theme further, and a lot of questions related to how do we get integrated in the world stage, I think there's an incredible opportunity we have here. We have seen ChatGPT has taken over the world. There's an opportunity for all of us. Take an example of ChatGPT here. We need packaging GPT. Everybody in the world will know what we are doing here in India and the value that we are bringing to the whole packaging research community and the development community all over the world. This is an opportunity. We can get on the world stage in matter of months here. So with that, I'd like to wrap up this panel discussion, and thanks to the esteemed colleagues here, Dr. Rao, Dr. Surya here, Devan, and Amrajit. Thank you so much.
Thank you very much, sir. And we'd also thank the panelists for sharing with us a progressive outlook for research and innovation in semiconductor packaging. Can you please step forward for a group photograph? Thank you. Once again, thank you very much, all of you. Thank you, sir. Ladies and gentlemen, we now take this journey forward for another exciting session on next-gen semiconductor for exploring the cutting-edge advancements and future possibilities in the semiconductor industry. The growth of autonomous and electric vehicles in India has steadily gained momentum, and semiconductors have now redefined the automotive industry, transforming our transportation and driving us towards a better future. We shall now showcase the video session of Mr. Lawrence